Okay, so to finish off the class here, we had mentioned a little bit last week about matrices and how those work to solve these systems of equations. I want to do one more example of those just to kind of clarify how it works with you. And actually, we can use them to solve the three variable systems of equations. So I want to show you how that works. And then we'll spend the rest of the time reviewing just to make sure you remember all the topics here in the last half of the semester for our final test coming up on Friday. So if you recall, with our matrices, we were dealing mostly with square matrices, because those square matrices could be used to find a determinant. And we were using those to describe these systems of equations. So I'm going to give you just a simple system of equations here. Oh, let's go with 3x plus y equals 1 and 2x minus 3y equals 21. So for this system of equations here, is that going to work? I'm going to make this 19, make it a little bit easier on us. Okay, so for this system of equations here, we had several methods we could solve. Being a two-variable system of equations, graphing would work. We also had substitution, and then we had that elimination or addition method. For matrices, we had to define three different matrices. And the first matrix we talked about was the base matrix. And to abbreviate, I'm just going to call that matrix M. And in that base matrix, we had the coefficients from the x variables. Now these had to be lined up just like we did with elimination. The x variables, the y variables, the equal sign, and then the constants, the numbers. So the x variables went in that first column. The coefficients of those x variables, I should say. So 3x, so we put 3 here. 2x, so we put 2 there. The second column was the y variables. This is just y. Well, what number goes with that? 1. That's really a 1y. And then that's minus 3y or negative 3. So there's our base matrix. To define the determinant, it was diagonal products. We had a down diagonal product, went this direction. 3 times negative 3 gives us negative 9. Then we had an up diagonal product. 2 times 1 is 2. So then the determinant was the down diagonal, the negative 9, minus the up. So negative 9 minus 2 is negative 11. Now then, there's two other matrices we want to define. We want to define the X matrix. Now, the X matrix might be viewed as a little bit of an ironic name because the X matrix actually excludes the X variable. So we're going to abbreviate M with a little X by it, MX. And in this matrix, instead of the X variables, we're going to replace it with the constants. So instead of the 3 and the 2, we're going to use the 1 and the 19 in the first column. The second column is still the y coefficients, so that's still positive 1 and negative 3. So let's look at finding this determinant. The down diagonal, 1 times negative 3 makes negative 3, right? Going up, 19 times 1 is 19. So our determinant is going to be the down of negative 3 minus the up of 19. What's that give us? Negative 3 minus 19 is negative 22. Good. And then we had the y matrix. And the y matrix, again, a little bit of an ironic name because it excludes the y variable. So we're going to label that as my, and we're going to now put the x coefficients back in, the 3 and the 2, and now we're going to replace the column with the y coefficients replaced with the constants. So that's going to be the 1 and the 19. So now 3 times 19 gives us 57, good. And 2 times 1? 2. So again, it's the down, it's 57, minus the up, which is 2. 57 minus 2 is 55. And now we find the value of y and of x and y. X was that determinant of the mx matrix divided by the determinant of the base matrix. So negative 22 divided by negative 11 gives us positive 2. And for y, it was the determinant of the y matrix divided by the determinant of the base matrix. So the y matrix was 55 and the base still negative 11. 55 divided by negative 11 gives us negative 5. Good. So the solution to this system is 2, negative 5. Now you can see that only took us about 6 or 7 minutes to solve that. A little bit tedious with the 2 variable systems because elimination or substitution goes pretty quickly with only 2 variables. But when we step up to 3 variable systems in this next example, in this final example, it does actually speed it up quite a bit. I mean, if you recall last week, some of these 3 variable systems, we only got maybe 3 or 4 examples done in the whole hour-and-a-half class period. So let's do a 3 variable system here. So I'm going to do 2x minus y minus z equals negative 8. X plus y minus z equals negative 9. And x minus y plus 2z equals 7. Just like with elimination, we have these lined up. We have all the x's, all the y's, all the z's, the equal sign, and then here's our constants. Our base matrix here because there's 3 variables, is going to have the column of the x coefficients. Now, so there's a lot of blanks here, so we're going to have to fill in a lot of 1s. So the x coefficients are going to be 2. 2x is 2. X is just going to be a 1 and another 1. So 2, 1, and 1. Next column is going to be the y coefficient. What numbers are going to go in that column for the y coefficients? The first one's negative 1 here from minus y. What goes next? Plus 1, and then the next one will be negative 1 again, minus 1 again. Perfect. Then the final column is going to be the z coefficients. That first one's going to be negative 1, and then negative 1, and finally positive 2. Good. Now, to find the determinant of a 3 by 3 matrix, it's a little bit trickier. If I just do a down diagonal and an up diagonal, you can see I miss 4 out of those 9 numbers. So to do a determinant of a 3 by 3 matrix, we actually have to do several down diagonals. You think of it as like, we still have the, oh, let me try that again. We have this main down diagonal. That one's pretty apparent. We move over to the next number in the top row to do a down diagonal, and we run off the edge of the matrix here. Think of like some of your video games where you wrap around to the other side of the screen. we're wrapping around and finishing up over here. The easiest way to think about that, the easiest way to handle that, is to simply rewrite these first couple of columns. So over here, I'm going to write this first column again, 2, 1, 1. So 2, 1, 1. And then the second column, negative 1, 1, and negative 1. So all I've done is taken this column and rewritten it here, and this column and rewritten it here. So now when I do my down diagonals, I have 2 times 1 times 2. What's that give us? 4. Good. Then in my second one, I have negative 1 times negative 1 times positive 1. So negative 1 times negative 1 is a positive 1. Times another positive 1 is a positive 1, right? Now here, the third one, we've got negative 1 times another negative 1. That gives us positive 1. Now those all add up to 6. That's my down diagonal for this matrix. That total of those 3 diagonal products. Now I'm going to go the other direction. Going up, I have 1 times negative 1. That's negative 1. 1 times 1 is 1, times negative 1 is negative 1. Then the next one, negative 1 times negative 1, that's positive 1 so far, times 2 is 2, positive 2, so plus 2. 2 times 1 is 2, times negative 1, negative 2. So now we're going to combine all of those. Negative 1 plus 2 is a negative 1. Minus 2, or sorry, negative 1 plus 2 is a positive 1. Minus 2 is a negative 1. So that's going to be the down of 6 minus the up of negative 1, which is 7. So the base matrix has a determinant of 7 for this system. Let's look at the X matrix. So MX. In the X matrix, I'm just going to use C for constant. Remember, in the X matrix, X is actually the variable that's excluded. So I'm going to put in the constants there instead of the X coefficients. So it'll be negative 8, negative 9, and 7. Then for the Y's, we're going to put in the Y coefficients, negative 1, positive 1, and negative 1. Then the Z's are negative 1, and 2 again. Now, again, I'm going to rewrite the first 2 columns. So here I'm going to repeat this column, negative 8, negative 9, and 7. Then I'm going to repeat this column, negative 1, 1, and negative 1. So now I'll do my down diagonals. Now, with the constants in there, they're a little bit bigger numbers, so this is going to be a little bit larger numbers multiplied out. So negative 8 times 1, negative 8, times 2, negative 16, good. Negative 1 times negative 1, positive 1 times 7, positive 7. Negative 1 times negative 9, positive 9, right? Then times a negative 1, negative 9. Now if we add these up, negative 16 plus 7 minus 9. Negative 18, good. That's our down diagonal. Let's go up. 7 times 1 is 7 times negative 1, negative 7, good. Negative 1 times negative 1, positive 1 times negative 8. Careful. Negative 1 times negative 1 is positive 1. Positive 1 times negative 8 is a negative 8. 2 times negative 9? Negative 18. Negative 18 times negative 1? Positive 18. Perfect. Now I have the negative 7 plus negative 8 plus a positive 18. Three. Perfect. So now I have here negative 18 minus 3 is negative 21. Perfect. Now it's time to go on to the Y matrix. In the Y matrix, remember, we exclude the Y variable. So we're back to having the X coefficients here. That's going to be 2, 1, 1. The Y coefficients are going to get replaced with the constants. So that's going to be negative 8, negative 9, and 7. Then the Z coefficients is going to be negative 1, and 2. Once again, we're going to rewrite the first two columns. So this column is going to get repeated. 2, 1, 1. Then this column is repeated. Negative 8, negative 9, and 7. Let's do our down diagonals. 2 times negative 9 is negative 18. And negative 18 times 2? Negative 36. Good. Negative 8 times negative 1? Positive 8. And positive 8 times 1? Positive 8. Good. And the last one, negative 1 times 1? Careful, negative 1. Yep, and negative 1 times 7? Negative 7, yes. So now we've got the negative 36 plus 8 minus 7. Beautiful, negative 35. Now let's do the ups. 1 times negative 9? Negative 9. Negative 9 times negative 1? Positive 9. Good. 7 times negative 1? Negative 7. Negative 7 times 2?
Negative 14.
Negative 14. 2 times 1?
2.
2, and 2 times negative 8?
Negative 16.
Negative 16. So then we add up. 9 minus 14 minus 16. Negative 21. Beautiful. So now we've got the downs, negative 35s minus the ups of negative 21.
Negative 14.
Negative 14. Good. Now we still have to do, because there's 3 variables here, we come up with a third matrix. It's called the Z matrix. And as you might have been able to predict, in the Z matrix, it is abbreviated MZ, and it is the Z coefficients that are replaced. So we have X's, it's going to be 2, 1, 1. We have the Y, so negative 1, positive 1, negative 1. And now we're going to put the constants in where the Z's were. Negative 8, negative 9, and 7. We rewrite the first column, 2, 1, 1. Rewrite the second column, negative 1, 1, negative 1. Let's do the down diagonals. 2 times 1?
2.
2, and 2 times 7?
14.
14, good. Negative 1 times negative 9?
Positive 9.
Positive 9, and 9 times 1,
0.
positive 9. Negative 8 times 1, negative 8. And negative 8 times a negative 1,
Positive 8.
positive 8. So then we have to add up. 14 plus 9 plus 8. 31 is correct. Good. Let's go up. 1 times 1, 1. 1 times negative 8, negative 8. Good. Negative 1 times a negative 9 is a positive 9. Positive 9 times 2,
Negative 18.
careful,
Positive 18.
positive 18. There you go. 7 times 1, 7. And then 7 times negative 1,
Negative 7.
negative 7. So here we've got negative 8 plus 18 minus 7. Is that 3? Okay. So now we've got the downs of 31 minus the ups of 3. 31 minus 3 is 28. Good. So now to find x, take the value from the x matrix of negative 21 divided by our base value of 7. Negative 21 divided by 7 is a negative 3. So x is negative 3. To find y, take the value of our y matrix, negative 14, divided by our base of 7. Negative 14 divided by 7 is a negative 2. And for z, the value of our z matrix is 28, divided by our base is 7, gives us 4. So we have a solution here of negative 3, negative 2, and 4. Any questions? Now I realize that's still a very long process, but in many cases a little less confusing than substitution or elimination because you don't have any choices to make. You know, in substitution and elimination, you both have to choose what variable am I going to get rid of or what variable am I going to solve for. Here, it's just straightforward. You put in the matrices and you find the determinants. Also, like I said, this is the way that computers and calculators actually solve these. Those of you that actually have a graphing calculator, I don't know if any of you do. Is there anybody in the room that has a graphing calculator? One of you? Okay. There is actually a really cool shortcut for doing these on the graphing calculator involving matrices. If we get time at the end of the hour today, I'll show it to you quick. Okay. I want to review for our test things that we're going to have to be able to do for our final test. If you understand the stuff we're going to do in the next hour, you are going to do wonderful on this test on Friday. So the first thing we're going to be looking at is graphing. We need to be able to graph, first of all, using a table. So, using a table, we can graph simple equations like 2x minus 3y equals 6. Now, using a table with this one, you may want to solve it to get it into y equals form, but you don't have to. So we're going to pick several values for x. On the test, I would give you values for x, but you don't necessarily have to use the ones I give you. Maybe we'll pick -2, 0, and +2. We need to find y. Well, if x is -2, what I'm going to do is replace x in this equation with -2 and figure out what y has to be. So 2 times x becomes 2 times -2 minus 3y equals 6. I'm going to make more room by getting those out of the way right now. I have to solve for y. So 2 times -2 is -4. So -4 minus 3y equals 6. Now I solve for y. What do I have to do next? Well, it's a -4, so we're going to add 4. Right? So that's gone. We have -3y equals 10. Well, now we would divide by -3 to get y equals -3 1/3. So what this is giving us is a point where x is -2 and y is -3 1/3. Well, that's kind of ugly, but we can still graph it. So we have -2, -3 would be right here, so we just go a little bit past. We can approximate it. -3 1/3 is somewhere in there. A little bit below -3. So we have that point on the graph. So we keep going. I said x is 0 was my next point I wanted to use. If x is 0, then y is going to be 2. 2x is going to become 2 times 0 minus 3y equals 6. Well, 2 times 0 is simply 0. 0 minus 3y equals 6. Well, that 0 doesn't do anything. I can ignore it. It's just, what we have right now is just -3y equals 6. So to solve for y, I'm going to divide by -3. Good. So y equals -2. So that gives us a point here that x is 0 and y is -2. So on my graph, x is 0, y is -2 is right there. Now from this equation, do I know, is this going to form a line or not? Yes, it will form a line. There's no powers on any of those variables. So this should form a line. But we're going to do a third point just to be sure. Now, I know I had said I was going to use y equals +2, so let's use that. So now we've got x, 2x becomes 2 times 2 minus 3y equals 6. Do the 2 times 2 to give us 4. So 4 minus 3y equals 6. What's next? Subtract 4. So -3y equals 2. And then divide by -3. So y equals a -2/3. So that gives us here that x is 2, y is a -2/3. So again, it's a fraction. It's a little bit difficult to graph, but here's 2. -2/3 is not quite down to -1. And there you can see those points do give us a line. And there's our line on the graph. So not so bad. Not all of those are going to form straight lines. You might have something like this. Y equals x squared minus 5. Now it's a little bit easier to graph this one since it's in y equals form. I can pick values for x, and it's a little bit quicker to figure out what y has to be for this one. So let's pick -2 for x. Y is going to be -2 squared minus 5. We're going to go ahead and square it. What's negative 2 squared?
-4.
Should be, you got to be careful on that one. You punch it in. Remember, you've got to put parentheses around the negative 2. So it should be a positive 4. There you go. Yep. And that's a tough one. That gets a lot of people. I always wait for that one. So we get positive 4 minus 5 is negative 1. There you go. So we get the point x is negative 2, y is negative 1. So I got to sketch out my graph. X is negative 2, y is negative 1. So there's a point right there. Let's use 0 for x. If x is 0, y is 0 squared minus 5. Well, what is 0 squared? 0. 0 minus 5? Negative 5. So we have 0, 5 here. So 0, negative 5. So 0, negative 5 is right there. Let's try the point x equals positive 2, since that seems to be working for us so far. If x is positive 2, y is 2 squared minus 5. What is 2 squared? 4. And 4 minus 5 is negative 1 again. So we get positive 2, negative 1. This is a point over here. We can see this is going to be symmetrical. Now, since this is an x squared in this equation, we remember this forms that parabola shape. And on a test, I know you guys are pinched for time. If you get three points like that, I'm okay with you just going ahead and drawing in the rest of the parabola like that. So that's one of the types of graphing you'll have to be able to do using a table. Now, the other type of graphing you'll have to be able to do is graphing lines from the slope and the y-intercept. Remember, we have that y equals mx plus b form of an equation. So, I'm going to sketch out a graph here again. So if I give you an equation like y equals negative 2x plus 3, where am I going to start with that one? Positive 3, good. It's the number that's not multiplying the x. So the positive 3 is where we start. Now the number multiplying the x is our slope, and we have to make it a fraction, so it's a rise over run. So we make that negative 2 over 1. So from this starting point at 3, where do we go? Down 2 and over 1. There's my second point right there. Whoops. And draw my line through those 2 points. Yes, sir.
If we do natural math on our final,
Yep.
how much does it actually grade?
Well, it's a 100-point test. It's one of only 2 tests this semester, so it has a big hit on your grade. You would have to get below 50%. For most of you, look at your grades. I think there's only one of you that really has to pass the course has to stay above a 60 on the final. But for most of you, you'd have to get below a 50% to drop below a C. Now, I don't like to say that too much, but there's a good share of you that have a good shot at a B and a couple of you with a shot at an A- if you do well on this test. Also, one of the reasons why we're doing the test this Friday instead of next Friday, which is our last day of the semester here, is hopefully so we get time, I can grade them and get them back to you, and you guys can do some quick corrections. I will give you up until 3 o'clock next week, Friday, to have corrections back to me. Okay, so we graphed that one. Let's do another one. We might have y equals 1 minus 3/4 x. Where would we start graphing that one?
Negative 3/4.
Careful.
Oh, positive 1.
Yeah, negative 3/4 is multiplying x. So it's the positive 1 is the number not multiplying x. That's where we start. And from there we go
Down 3 and over 4.
down 3 and over 4. Beautiful. So I take out those marks and we just go through those 2 points. So there's my line. I might have y equals 1/2 x minus 3. Where am I going to start?
Negative 3.
Negative 3, good. And from there I'm going to go,
Down 1 over 2.
careful. That one's a positive 1/2, right?
1 over 2.
Up 1 over 2, very good. So again, my line can go through those 2 points. It is possible to get one like this. And to graph this, we would have to solve it first. What would be the first step to solving this equation for y? After you,
Subtract 3x.
perfect, I subtract 3x. So I've got 2y here. 4 minus 3x is just going to be 4 minus 3x. The next step would be divide by 2. Remember, when we divide or multiply, we have to do it to each digit. So 2y divided by 2 is just y. Over here, we got to take each digit. 4 divided by 2 is 2. And negative 3x divided by 2?
Negative 3 over 2x.
Negative 3 over 2x. Good. So where do we start when we graph this?
Positive 2.
Positive 2. And then from there we go
Down 3 and over 2.
down 3 and over 2. It is a negative 3/2. So we go down 3 and over 2. Okay. So that is kind of the extent of the graphing that I'd have you do. The other thing we need to remember is we have a bunch of formulas that we have used. I need to be able to find the slope of a line from its points. So we might have the point 3,7 and negative 2, negative 3. And I want to find the slope of the line that goes through those points. Now, if you recall our slope formula, m is equal to y2 minus y1 over x2 minus x1. So to do this, I label them points 1 and point 2. So my slope, what goes first up on top here?
Negative 3.
Yep, negative 3. y2 is 0.2, y coordinate, minus the 7. Good. On bottom, what goes first here?
Negative 2 and then minus 3.
Negative 2 is y2 or x2, and then minus 3 is x1. Good. So negative 3 minus 7 is
Negative 10.
negative 10. Good. Negative 2 minus 3?
Negative 5.
Negative 5. And we divide that out. Negative 10 divided by negative 5 is a positive 2 slope. Wonderful. I might ask you to find an equation from a graph. So if I have a line on the graph that looks like this, remember y equals the slope times x, and then plus or minus that y-intercept. Well, from the graph here, I can read the y-intercept real easy. What's that y-intercept on the graph? It's a positive 3. Good. So that's plus 3. The slope requires a little bit more work, but I have a triangle right here I can draw in. A rise and a run. What's my rise here? Three of them, right? 1, 2, 3. But I'm going down, so it has to be negative 3. Good. My run is 2. So the slope there is negative 3 over 2. So it's negative 3 over 2. So that equation is y equals negative 3 over 2x plus 3. It might not be quite that simple with being on the axes. It might look something like this. Where I have it go through like this. So looking at this again, we have that form, y equals the slope times x plus or minus the y-intercept. What's our y-intercept going to be here? Positive 4. Good. Perfect. So plus 4 goes there. The slope is then going to be from this little triangle again. What's my rise? 1. Is it positive or negative?
Positive.
It is positive. And my run here?
1, 2.
2. There we go. So my slope is 1 over 2. So I put 1/2 here. So that gives me the equation y equals 1/2 x plus 4. Okay, it's time for breaks. Why don't you guys go ahead and take a quick few minutes and we'll get back to her. Okay, looks like we got most of you back in the room, so let's start rolling again. So, some things that, again, might be on this test. Let's look at midpoint formulas. If you remember, if we had 2 points, you could find the midpoint between them. Oops, come on now. Let's say we have a 3, -7, and 11, 1 are my points. The midpoint is simply the x coordinate of the midpoint is the average of the x coordinates. The y coordinate of the midpoint is the average of the y coordinates. So for these 2 points here, I have 3 and 11 are my x coordinates. So 3 plus 11 divided by 2. 3 plus 11 is 14. 14 divided by 2 is 7. So that is the x coordinate of my midpoint. For the y coordinate of my midpoint, I have y coordinates in my points of -7 and 1. So I'm going to do -7 plus 1 over 2. What is -7 plus 1? -6. And -6 divided by 2 is Negative 3. So negative 3 is the y-coordinate of my midpoint, right there. I may... Now let's do one more example of that, just to make sure here. Let's do 3, negative 11, and 7, 3. Find the midpoint. Where do I start? Positive 3. Plus 7. Divide by 2. Good. So 3 plus 7 is 10. Divide by 2 is 5. Wonderful. So the x-coordinate of our midpoint is 5. What's next?
Negative 11, 3.
Negative 11 plus 3. Of course, divided by 2.
8, negative 8 divided by 2.
Perfect.
4.
Perfect. Negative 11 plus 3 is negative 8, and negative 8 divided by 2 is negative 4. So 5, negative 4 is that midpoint. Now remember, we called this points A and B, and this was the midpoint, point M. I might give you that point A is 2, negative 5, and give you that the midpoint is 4, 7, and ask you to find point B. This was a little trickier. So I'm just going to label point B here as X and Y for those missing points. I know that I find the x-coordinate of the midpoint by averaging these x-coordinates. So it's 2 plus x over 2 has to equal the 4. And now I solve the equation. What do I do first? Not divide, but multiply, yes. Since that was divided by 2, I multiply by 2. So I have 2 plus x equals 4 times 2 is 8. And then subtract 2, good. So x equals 6. So this is 6 here. For y, I know I averaged the y-coordinates of those two endpoints. So negative 5 plus y divided by 2, that has to equal the y-coordinate of my midpoint, which is 7. So I start out by multiplying by 2. So negative 5 plus y equals 7 times 2 is 14. This time I have to add 5 because it's a negative 5. So I get y equals 19. So this is 19 here. Any questions? Okay. The next formula we had that we worked with was distance formula or length formula. So if I had 2 points, the distance between them was the square root of x2 squared, x2 minus x1 squared plus y2 minus y1 squared. Remember, this is that Pythagorean relationship. A squared plus b squared equals c squared. But instead of putting the squared here, we use the square root. So now if I give you 2 points, let's say I'm going to give you negative 2 and 8. And I want to go to point 3, negative 4. So to find my distance, what's going to go in this first set of parentheses? Yeah, 3 minus a negative 2. That'll be squared. Plus, what goes in my second set of parentheses? There you go. Negative 4 minus 8. Thank you. Close that parentheses. That is squared. So then we have to go ahead and calculate this out. 3 minus a negative 2 is 5. Good. Negative 4 minus 8. Negative 12. Good. So that's going to be squared. So now let's square each of those. Well, 5 squared is just 25. Now be careful with the negative 12 squared. Remember, it's negative, so you got to use 144. Good. You remembered the parentheses. So we get a positive 144. Now we have to add those. 25 and 144 is 169. And finally, we take the square root.
13.
Distance is 13. So those 2 points are 13 units apart. Let's do one more example of that. Negative 1 comma 9 and 14 comma 1. So I'll call them point 1 and 2. In my first parentheses, what goes first? 14 minus negative 1. Good. So that's going to be squared plus. In my second parentheses, what do we have? 1 minus 9 squared. Yep. Perfect. Now, let's do our subtraction. What is 14 minus a negative 1? 15. Good. What is 1 minus 9? Let's get up off the floor, guys. Okay. So now we've got 15 squared, which is 225. Good. And the negative 8 squared? 64. Good. Then we add those together to get 289, and then we square root 17. So the distance is 17 units apart. Now I'm going to go back up here. I know I did this the long way here by going step by step. But back up to here, we could do this all in one step in our calculator. Second square root, parentheses, 14 minus negative 1. Notice on my calculator, I don't need parentheses around that negative. Squared, plus parentheses, 1 minus 9, close the parentheses, squared. Hit equals, and it should spit out the 17, and there it is. So you don't have to go step by step like I did. You can just put, once you put the numbers in the formula, you can just type it in the calculator. Okay, so that's our distance formula. And if you recall, we use that to find equations. Right, we find the equation of a line through thank you. Through the points, let's go 4, 7, and 8, 5. Well, the first thing we have to do is to find the slope. So the slope, I call this point 1 and point 2. Remember, on top, it's y2 minus y1. So what's going to go on top up here? 5 minus 7. Good. On bottom, it's x2 minus x1. So what goes on bottom?
8 minus 4.
8 minus 4. Good. So 5 minus 7 is
-2.
-2. 8 minus 4 is 4. That can be reduced. -2 over 4 can be reduced to -1/2. Wonderful. That is my slope. So I know now that my equation takes the form y equals that slope times x, so -1/2 times x, plus whatever that y-intercept is. So I put in b. To find b, we've done several of these where we had a slope and a single point. Here we have 2 points, and it doesn't matter which one we use. I'll just take this one since it's right there. What goes in for y?
5.
The 5. Good. So then for x, we're going to put in
8.
the 8. So now we're going to do the -1/2 times 8, which is
-4.
-4. So 5 equals -4 plus b. And what's next?
Add 4.
Add 4 since it's a -4. So 5 plus 4 is 9. That cancels out. So b equals 9. So we bring that up here and we replace b in that equation. So that becomes y equals -1/2 x
Plus 9.
plus 9. Good. Wonderful. You might get asked, find the equation of a line parallel to y equals 2/3 x plus 7 and through the point 6, -1. Well, when we're doing this, we have this equation we're given here. There's only one piece of information that we want out of that equation. Can anybody tell me what it is? The slope. And of course that is the 2/3.
2/3.
Perfect. So slope is 2/3. Now for the parallel, what's the slope of a line parallel going to be?
2/3.
Also 2/3. The slope of a line parallel is the same. So now we start out y equals
2/3 x
2/3 x
plus b.
plus b. Wonderful. So then what do we do?
-1 goes in for y, and
Perfect.
6 goes in for x.
Great. -1 goes in for y. 2/3 times the 6 goes in for x. Good. Then what?
2/3 times 6 is 4.
2/3 times 6 is 4. And then
You subtract 4.
subtract 4. So -1 minus 4 is
-5.
-5. That 4 is gone. So -5 equals b. So that comes up here. So the equation is
Y equals 2/3 x minus 5.
y equals 2/3 x minus 5. Great job. You might be asked, find the equation of a line perpendicular to y equals -3/4 x plus 7 and through the point 9, 4. So again, from this equation, there's only one piece of information we want. And what is it? The slope. And the slope is? Negative 3/4. For the perpendicular, perfect. It's going to be a positive 4/3, exactly. It has to be the opposite. So this one's negative, this one has to be positive. And reciprocal. 3/4 becomes 4/3. Good. Then what? Y equals 4/3. So, yep, 4 goes in for Y, 9 in for X. Good. And then? 4/3 times 9 is 12. Good. And then? Subtract 12. Negative 8 equals B. Wonderful. So that comes up here to give us the equation y equals 4/3 x minus 8. Great job. Okay. So then that brings us up to the point where we started with solving system of equations. We might be asked to solve a system of equations that looks like this. Y equals negative 2/3 x plus 5 and x equals 6. So this top equation, how am I going to graph it? Perfect. I start at positive 5. I go down 2 over 3. Now I'm going to do that again. From that point, I'm going to go down 2 over 3. So my line goes through those points. So again, this stuff isn't here, so I'm going to take that out. That was just help me graph it. This one's a little tricky. X equals 6. How do I graph that? Well, whenever I have a variable equals a number, it's either going to be a horizontal line or a vertical line. Yeah. Careful, you had it right the first time. Vertical. So x equals 6 is right here. It goes up and down from there. So where these cross, and one thing when you guys did the quiz a couple weeks ago, I did take points off for this, but on the test I will. You drew the lines, but you have to identify where they cross. These two cross at the point x equals what? Yeah, other way around, 6, 1. X equals 6 and y equals 1. So 6, 1 would be our solution there. So make sure on this test that you put that in there. You might have something like y equals 3/4 x minus 2 and y equals negative 1/2 x plus 3. So this top equation, where do I start? Negative 2. And from there I go where? Up 3 over 4. So there's my second point. Perfect. The second equation, I start out at up 3, and from there I go down 1 over 2. Now I'm not down to this line yet, so I'm going to go again. Down 1 over 2, and that's where they do cross, is at that point. So, where do those two cross? What's that point at, guys?
4 and 1.
4 and 1. Perfect. So again, that's the biggest thing I wanted to point out from your quizzes is make sure you name that point. Okay, so then we had other methods. We had substitution. I might give you a system of equations that looks something like this. X plus 2y equals 7. 7x plus y equals a negative 3. And to solve that, what do I need to do?
You can turn 1 to the negative, so we can get a variable cancel out.
Well, you're thinking addition or elimination. If I want to do substitution, I have to either get one of them as x equals or y equals, right? So I'm going to take the top one here, and I'm just going to solve it for x. So I am going to get rid of the 2y, subtract the 2y. So x is equal to 7 minus 2y. What am I going to do with that? Yeah, I go back to the other equation and I put that in for x. So instead of 7 times x, it's going to be 7 times 7 minus 2y. Good. I still have plus y and equals a negative 3. What's my next step here?
7 times 7.
We distribute. Good. 7 times 7 is
49.
49. And then?
7 times negative 2y is negative 14y.
Perfect. 7 times negative 2y is negative 14y. I still have the positive y equals negative 3. Then what?
Negative 14 plus y is going to be negative 13.
That's negative 13y. I still have the 49 and equals negative 3. And then?
Subtract 49.
Subtract 49. What's negative 3 minus 49?
Negative 52.
Negative 52. And my last step here?
Divide by negative 13.
Divide by negative 13. What is negative 52 divided by negative 13? Positive 4. Good. Y is positive 4. So I'm going to come back up here and I'm going to replace y with positive 4. So x equals 7 minus 2 times 4. What's the next thing I'm going to do here?
Negative 2 times 4.
Yep, and that gives me minus 8, right? Perfect. And next? 7 minus 8 is negative 1. So x is negative 1. So the solution there, x is negative 1 and y is 4. Again, make sure you write out that coordinate so that you know that solution. Now on a test, you had said, try to multiply one of them here so that they cancel out. If you did that when I asked for substitution, I wouldn't take off much if you still got the right answer. But when there are going to be a couple where I specifically ask for substitution, I'd like to see at least try them a substitution before you go to the elimination method. Next, the last thing we did is elimination. So elimination or addition, depending on who you're talking to and what textbook you're reading. They're the same thing, just by different names. So I might give you x minus 2y equals 8 and 2x plus y equals 1. What am I going to do here? Perfect. Perfect. If I multiply that bottom equation by 2, This will make this a positive 2y, and that'll cancel with the negative 2y. So I'm just going to rewrite this top equation because that one's not changing. The bottom equation here, 2 times 2x is 4x. 2 times y plus 2y, good. Equals, well, not 1, but 2 times 1 is 2, good. Perfect. Now we can add the columns. X plus 4x is 5x, good. They cancel out. Equals 8 plus 2 is 10. Then what? We divide by 5. Gives us x equals 2. Wonderful. What do we have to do with that?
Put that back into one of the original equations.
Perfect. We have to go back to one of these original equations to find y now. Which one do you want to use?
Top one.
We'll use the top one. So that's going to become 2 minus 2y equals 8. What do we do next? Subtract 2. So negative 2y equals 8 minus 2? 6. And then? Divide by negative 2. So y equals? Negative 3. So our coordinate is?
2 comma negative 3.
2 comma negative 3. Wonderful. And I will warn you, there will be one 3-variable system of equations on the test. It is one that you have seen before. We have done it in class at some point in the last 2 weeks. So if you have notes, it's there. Otherwise, if you get the free time, you can look through the recordings to find it. I'm going to let you guys have those quizzes to correct. You're pretty much done correcting them? Okay, and I've got one quiz that just got sent to me that I have to grade yet and send back to you. I was going to let you guys have the last 10 minutes here to correct those quizzes if you'd like. Otherwise, if you got stuff to work on and you can sit there quietly, let's go ahead and we'll take that last 10 minutes here to work. Okay. I can tell you guys have had enough for the day anyway.